radicals. So you have to know how to simplify radicals before you can multiply radicals. So if you're still struggling with simplifying radicals, I suggest that you go back and take a look at how to simplify them and get really good at simplifying radicals. Maybe rewatch that video and then come back to this video and watch this video, because if you had to have a good understanding on simplifying radicals before you can multiply them. So we're going to look at a new property, and it's called the product property of radicals. Product meaning multiply. So here's what it says. As long as your variables are greater or equal to 0 and their index values are the same on two different radicals, then you can simply multiply the radicands together under the same radical, and of course keeping the same index. So let's look at an example. We have the square root of 2 times the square root of 6. So the index are the same. It's that invisible 2, which means we can simply multiply the radicands together, the 2 and the 6. 6 breaks down to 2 times 3. And since our index is 2, and 2 times 2 is the same as 2 squared, this 2 base has an exponent of 2 that can pay the index tax of 2. So we can actually simplify the square root of 2 squared as 2. And then we still have the square root of 3. Alright, so this next example, we have negative 2 square roots of 18 times 5 square roots of 50. Now the negative 2 and the 5, we will just simply multiply to negative 10. And then the square root of 18 and the square root of 50, since the index is both 2, then that means we can multiply 18 and 50 together. But before we do that, we do need to break down 18 and 50 into prime numbers. You can use a factor tree if you like. 18 breaks down to 2 times 3 squared, and 50 breaks down to 2 times 5 squared. And now we need to simplify. So since this is a square root, the index is 2. So we're looking for groups of 2 who can pay the index tax of 2. So a 3 is going to be able to come out. A 5 will be able to come out. And then we actually have a 2 times 2, which is 2 squared, which means a 2 will be able to come out, leaving nothing on the inside. So we have negative 10 times 2 times 3 times 5, which equals negative 300. Alright, so when you have a variable, it's actually, that variable can be a positive or negative number, but for the purpose of this lesson, since we're just in Algebra 1, we're going to assume that all variables represent non-negative values, and so we don't have to use the absolute value symbols around them. Alright, so we're looking at this example, the square root of 6ab times the square root of 2bc. So again, we're assuming that the a and the b and the c represent non-negative values. So since the index is the same for both of these radicals, we can multiply the radicands together. We'll break down that 6 to 3 times 2. And then we have 2, we have a, we have b squared because we have b times b, and then we have c. So since there is a square root, we're looking for exponents of 2 or groupings of 2 to see who can simplify and become out of the radical. So this 3, there's no other 3, so he has to stay inside. There is a 2 times 2, which means a 2 gets to be out. There's a b squared, which means that the b gets to come out, and then the a and the c also have to stay inside. Alright, so when you're multiplying radicals, these are your steps. You apply the product property, writing the radicand as the product of prime factors. Then you simplify the root of each perfect power, and then simplify the resulting expression. All right, so for this one, we have cube roots. So the index is 3. So the first thing we want to do is simplify 225 and 315. We can use a factor tree to help us. So 225 breaks down to 3 squared times 5 squared. And 315 breaks down to 3 squared times 5 times 7. So remember, we're looking for groups of 3 to be able to simplify to be out of the radical. So we have 3 squared and 3 squared, which is the same as saying 3 cubed times 3. And we have 5 squared times 5, which is 5 cubed. And then we have 7. So notice I wrote this in terms of cubes, if possible, so that way I can see what will simplify and what will be able to simplify and become out of the radical. So this 3 will be able to come out, and this 5 will be able to come out, leaving the 3 and the 7 on the inside. And now that I have 3 times 5 on the outside, I have to simplify that, and that becomes 15, and 3 times 7 on the inside becomes 21. So the more complicated your radical becomes, you can use the product property and other properties that we have learned so far to help simplify and multiply. For example, if we have this, the square root of 5 times the square root of 3 times minus 2, you can use the distributive property to distribute this radical. So then that means we have the square root of 5 times the square root of 3, which is the square root of 15, minus 2 square roots of 5. So this one, we're going to distribute the 2 square roots of 6 to the square root of 15, which that's going to become 6 breaks down to 2 times 3, and 15 breaks down to 3 times 5. And then we're going to distribute this 2 square roots of 6 to this minus 3 square roots of 10. So 2 times negative 3 is where the negative 6 came from. 6 breaks down to 2 and 3, and 10 breaks down to 2 times 5. Alright, so since this is a square root, we are looking for groups of 2. Here's a group of 2 on this 3, so that means this 3 gets to come out, leaving 2 and 5 on the inside. And then over here, we have a group of 2 2's. So the 2 gets to come out, leaving the 3 and the 5 on the inside. So then we'll simplify. 2 times 3 is 6. 2 times 5 is 10. 6 times 2 is 12. And then 3 times 5 is 15, giving us our final answer. So an application that we use for radicals is Heron's formula. And Heron's formula is a formula to calculate the area of a triangle if you know the length of 3 sides. So the formula looks like this. So we're calculating for area of a triangle, and then S is the formula A plus B plus C divided by 2, where A, B, and C are the lengths of the triangle. Let's say we have a triangle that has the lengths 6, 8, and 10, and we want to find the area of that triangle. So first we would find S. So we do 6 plus 8 plus 10 divided by 2, which would give us 12. And then we plug in our formula. So remember, S is 12. So we should have S minus A, so S minus 6. And then S minus B, and then S minus C. So remember, B was 8 and C was 10. So we will multiply that to get 12 minus 6 is 6, 12 minus 8 is 4, and then 12 minus 10 is 2. And then we'll multiply that together, and then take the square root of it, and we end up with 24.